So Ram is with Space Foundry, and he'll be telling us about his very unique and very interesting digital plasma deposition technology. Um, Hello,
Hi,
nice to see you.
good to see you, Kasha. Okay, thank you. Yeah. So, hello everybody. So, my name is Ram Prasad Gandhiraman. I'm the founder and CEO of Space Foundry. So, Space Foundry is a NASA spin-off at Silicon Valley, yeah, in San Francisco Bay Area. We are primarily an equipment manufacturer. We manufacture and sell plasma jet printers. Our value proposition is in our ability to print conductors and dielectrics in a single step in a dry pattern, which doesn't need curing. We have about 15 installations made across the world, and we are just growing. So before we get into the details, let me just get the business part out of the way. So we sell these R&D tools, desktop systems, um, and we also do OEM integration. We integrate our printhead onto other additive manufacturing tools, robotic arms, and other gantries. We have done that on three different tools, like a robotic arm, and it's a large gantry that's used for printing on aircraft wing, and also recently on a roll-to-roll printer for a defense customer. So as you all know, like this, we are, like all of you, we are addressing this emerging market in the printed electronics, which has application, ranging from automobile to semiconductor to wearables. All of this require printing onto their preferred platforms. Sometimes the substrates are not conducive for printing. One of the, being a small startup, we have to focus on one thing. So we decided to focus on aerospace and defense application, where we see that they are going to be the early adopters of this technology. So if you look at the very first generation of the fighter jets, you can see that all these have planar surfaces, manufactured initially and then assembled together. These fighter jets, they require, the primary capability is electromagnetic invisibility. They need to have reduced cross section. They need to be able to do electromagnetic shielding, and they need to have radar absorbing materials. So, and then, the recent version of the fighter jets, they basically, they look much more, um, like a, there's been a lot of effort going on into getting rid of those complex features. So the next generation aircraft, basically fighter jets require, the industry is moving towards embedding these electromagnetic invisibility patterns directly onto the aircraft structures. It can be a drone or a guided missile, or any of these large airborne RF structures, basically. So these require what you call as passive antennas, frequency selective surfaces. These are basically metamaterials that are printed onto the dielectric substrates. So, there are some challenges associated with this. Curing, adhesion is a big issue, because you are printing onto composites, which are traditionally not conducive for printing. And then building thickness is another major issue, because you got to be able to build thickness in the range of 100 to 200 microns. Printing inside the nose cone, there are some challenges. Again, some of these defense industries would require printing these FSS patterns directly onto the airborne structures. And these FSS patterns are basically, what you see here on these, basically these are very simple patterns. Like you see, can be as simple as a cross, like it's a 10 millimeter long, 1 millimeter wide cross, but these are phased array. They are repeated over a large structure. So